All right, so this is a review of Chapter 7 for the test, and it's Part 2. Reminder that this stuff is the Quiz 1 topic stuff over here, and on this other side is the Quiz 2 topics. I would tell you right now that I'm not going to review these. I went over this, reviewed during test review part 1. So if you want to see this, go to that video to remind yourself of this. And this was gone over in the quiz 2 review video. So I'm not going to step through it. If you want to hear me explaining it, go back to those videos and watch the beginning of them. Otherwise, review that on your own to help you be prepared for the test tomorrow. So let's go ahead and start doing problems. Number 1, we're trying to find domain. You need to pay attention to the index. In this case, my index is 10. So since this is an even index, that means that my numbers on the inside have to be greater than or equal to 0. So 14 minus 6x should be greater than or equal to 0. So we would subtract 14. Negative 6x greater than or equal to negative 14. We would divide by negative 6. And again, if you divide by a negative, you need to flip your inequality. So this would be x is less than or equal to. A negative divided by a negative is a positive, and 14 over 6 we reduce to 7/3. Now remember, your answer must be in interval notation. If you're going to give domain, domain should always be in interval notation. So if you need to, you could draw a little sketch on the side. 7/3, since it's an equal sign, it'll be solid, and less than goes in this direction. So this side of my interval would be negative infinity, and this side is 7/3. So I put a parenthesis next to my infinity, and since my 7/3 is a solid circle, we put a square bracket. Okay, looking at the next problem, here you should see that I have an odd index. If you have an odd index, there is no limits. There are no constraints on the variable because you're allowed to have negatives and positives. So your answer is everything from negative infinity to positive infinity. Number 2, they're asking you to simplify. So I would tell you I would change this to radical form. However, you need to be very, very careful. This is a very important problem because this is a place where students make mistakes all the time. You need to realize that the only thing being raised to the exponent is the 25. The negative is not there. This is essentially like saying negative 1 times 25 to the 3/2. All right, so when I do this, then I would have negative 1, and only the 25 goes in the radical. Only 25 in radical, because negative not attached using parenthesis. Okay, so then this becomes the index is the denominator, the square root of 25 to the 3rd. So now we can actually take the square root of 25 because what number times itself would be 25? That would be 5. So we have 5 to the 3rd. We still have the negative 1 out front. Order of operations should tell you to do the exponent. So 5 to the 3rd is 125, and then you multiply that by negative 1 to get negative 125 as your answer. The only time the negative would go on the inside is if there were parentheses with the negative around it. All right, so let's go ahead and look at the next page. Okay, so let's look at number 4. Number 4, I always tell you, check if denominator can simplify. Because if the denominator can simplify, then that makes everything so much easier because then we don't have to worry about rationalizing. So, is there a square root of 64? And there is. What number times itself is 64? Well, that would be 8. And then, because my index is 2, 2 can go into 16 8 times. So you would also have n to the 8th. Then we can go ahead and deal with the numerator. Now when we deal with the numerator here, there is no square root of 40, so we're going to have to break it up. So we should make a list of squares. So squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and I don't need to go any further because we're looking at 40. So I need to find the largest one of these that would go into 40 evenly, and that would be 4. So my 40 would break up into 4 and 10. So this would become 2, and I'm going to put the square root of 10 further over because then I have to deal with the m to the 5th. So I have to figure out how many times would 2 go into 5. Well, 2, 4. So it goes in twice, so we have m to the 2nd, and we were at 4, and to get to 5, there's 1 more left. So we would still have an m to the 1st, but remember, we don't write an exponent of 1. So my answer would just be 2m squared, square root of 10m over 8, n to the 8th. Now make sure that you are careful about this as well. As soon as there's no radical in the denominator, then you should be good. Okay, so let's go ahead and look at number 5. This, on the other hand, is doing a cube root, so I need to make a list of perfect cubes. So 1 to the 3rd is 1, 2 to the 3rd is 8, 3 to the 3rd is 27, 4 to the 3rd is 64, 5 to the 3rd is 125. So 108 is not one of them, so I'm going to need to split this up into the largest one of these. So I have to try each one and see which one would work. Well, about half of this is close to 64, so I would try 64. So clear it out. So 108 divided by 64 doesn't work. So then I would try the 27, and it did work 4 times. So this would break up into 27 and 4. Now be careful because the negative needs to go with one of them. And since this is a third root, we put it with the one we're taking the cube root of. Because negative 3 times itself 3 times would get me negative 27. Then I can go ahead and put the third root of 4 over here and then start dealing with the rest of this. So the exponent on the d is a 1, so that can't go in there, so I have d to the 1st here. Then I figure out, can 3 go into 10? Well, let's count up. 3, 6, 9. So yes, 3 can go into 10 3 times, so I can pull out 3 of them, but I'm at the number 9, and we would need 1 more to get to 10, so then this is p to the 1st. And then I would see how many times can 3 go into 18. So 3, 6, 9, 12, 15, 18, so that'd be 6 times, and there is no remainder, so r to the 6th. Now normally we don't write the exponents of 1, so my final answer would be negative 3 p to the 3rd, r to the 6th. And I'm going to write my radical way far away so that it's clear that my index is the 3, and it's not meant to be an exponent. Okay, let's look at the next one, number 6. Excuse me. The index here is 4, so I need a list of perfect fourths now as well. So 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81. So 32 is not a perfect fourth, but 16 does go into it evenly. So this would be the 4th root of 16, and 16 goes into it twice. Well, the 4th root of 16 is 2, and then I would put the 4th root of 2 over here and give myself some space. And then I have to figure out how many times does 4 go into 11. Well, 4, 8, that would be twice. So I have 2 of them out here, but it only got me to 8, which means how many more to get you to 11 would be 3. So my remainder would have been 3, so then we would have m to the 3rd. And that's our final answer, and I'm able to leave it that way this time because here there wasn't a lot of space. I don't know whether it was r to the 6th, r to the 63rd. Here there's a decent amount of space, so we know what was intended. All right, let's look at number 7. Here, there's multiplication between, so we're going to have to distribute. So we're doing negative 2 radical a times square root of a. Well, there's not another outside number, so we can bring down the negative 2, or you can view it as a 1, and negative 2 times 1 is negative 2. Remember, we add exponents when we multiply. So this is like 1 plus 1. Right? 1 plus 1 would give me the square root of a squared. And since my index is 2, 2 goes into 2 once, so this would be negative 2a. Then I can go ahead and start working on the second part of it, doing negative 2 radical a times, now be careful because it's a negative, so negative radical a b to the 6th. So negative 2 times negative 1 would be a positive 2. Again, we add exponents. 1 plus 1 would give me a squared. There's nothing to combine the b with, so we bring it along. My index is 2 still, so 2 goes into 2 once. So we have an a, and 2 goes into 6 3 times without a remainder. So I have negative 2a plus 2a b to the 3rd, and then that's your final answer. Now we're getting into the i's, so you've got to remember that I squared equals negative 1, so I want this in terms of I squared. So how many I squareds would it take to get to 30? Well, the easiest way to do that is to divide and say it would take 15 I squareds. So this tells me negative 1 to the 15th power, and negative 1 to the 15th power is negative 1. Number 9, this one we have to distribute. And remember, when we take an exponent to an exponent, we multiply our exponents. So I'm doing 8 times 1/4, which if you wanted to, you could type it in your calculator. 8 times, in parentheses, 1/4 is 2. So I'd have f to the 2nd. 8 times negative 3 would give me g to the negative 24th. 12 times 3 would give me f to the 36th. And 12 times 5, 6. Well, 12 divided by 6 is 2, times 5 would give me 10, so g to the 10th. Notice that my parentheses dropped out, and since there's multiplication between them here, there's also multiplication between them there. Now that we're at this point, if you are multiplying, remember that means that we would, if you're multiplying, that means you add your exponents. So I need to add 2 and 36 to get f to the 38th. Then I need to add the negative 24 and the 10 to get g to the negative 14th. Oops, we weren't going to be able to read that. So the negative 14th. And remember, you're not allowed to have negative exponents. So we move it to the bottom, pretend like this is a fraction, and move it to the bottom. So this becomes f to the 38th over g to the 14th. Last simplifying problem before we move on to solving. So as soon as you see that there's a plus sign in the denominator, you should realize that you will have to multiply by the conjugate to clear the radical. So the conjugate of this would be 3 minus square root of 8, 3 minus square root of 8. So square root of 8 times 3 would be 3 square root of 8. Square root of 8 times square root of 8 would be negative square root of 64. So now we need to simplify this. Well, one of these are really easy to simplify because the square root of 64 is 8. But 8, a lot of people will want to leave, but you can actually break up the 8. Look at your list of perfect cubes from the top. Oh, not cubes. We're not doing cubes. Sorry. Look at your list of perfect squares from the top. The index is 2, so we look at the 2's, and 4 would go in there. So this breaks up into square root 4 square root of 2, and don't forget that your 3 is there, which leaves us with 3 times 2 root 2. So now I have 6 root 2 minus 8 on the top. And then we have to go ahead and do the same process with the denominator. So 3 times 3 is 9. 3 times negative root 8 would be negative 3 root 8. Positive root 8 times 3 would be plus 3 root 8. And root 8 times root 8 would be negative root 64. So these would cancel because they both are like terms, and negative 3 plus 3 is 0. The square root of 64 is 8, so we have a 9 minus 8, which is 1. And anything divided by 1 is itself, so your final answer is 6 root 2 minus 8. You just have to remember to reduce the radicals whenever you can before you give your final answer. All right, and now you're going to go ahead and you're going to go to your next video to watch the rest of this review, because we're going to transition from simplifying back to solving.